How's everyone feeling? Pretty good? Still energetic in the afternoon, not too sleepy from lunch, I'm hoping. So my name is Jerry. I work as a senior engineer at Intridia. We do mostly Rails consulting. I've been working there for a couple of years now. I've been doing Rails and Ruby for the last 5 years, so for a few years now, but definitely not as long as some of the veterans out here. It's really humbling to talk to some of these really awesome, smart people in the hallways and just get their perspective and experience on everything. Anyways, my talk is about evented Ruby and how it compares with Node.js. I wanted to kind of give some background about these topics and also give some advice about how you can bring some of the performance benefits from Node into your existing Rails app. And everyone here loves Ruby, and I want Ruby to be the core of this talk. So as far as performance optimizations go, I'm a big fan of being as lazy as possible. If my users are happy, then obviously I'm going to be happy with response times. Too many times I see people go after these kind of premature optimizations or micro optimizations that give you some benefit in production, but not enough to really justify the work or the level of effort. Given the choice, I'd much rather write new features or learn new technologies than kind of chase after these things. That said, the web is getting more complex and more real time. So we do need to keep our apps running fast so we don't drive away potential users. And to do that, when I do have to look for optimizations, I want to look for things that are easy to implement, but also easy to maintain, and things that give me the most bang for the buck. Fortunately, a lot of the changes I'm talking about today are reasonably straightforward and minimize code changes, and in some instances, you don't have to change any of your server infrastructure at all. So an overview of the topics I'm going to go over. There's a couple things that it says on the program that I had to cut out, but I'm happy to talk about those after the talk. I'm going to start with some background about what evented programming is, and then talk about why that's important for server-side coding, in particular for web backends. Then I'm going to talk about evented Ruby and the pros and cons against evented JavaScript, and how these two languages differ in how they do things. Finally, I'm going to kind of go through this longer example of how to add evented Ruby for a Rails app, because while it's kind of straightforward to write an evented Ruby script or like a utility to do things, it's a little bit more involved to kind of get the evented paradigm into kind of this procedural Rails ecosystem. So evented programming, what is it? All it is registering function callbacks for events that we care about. So we do this every day when we're doing client-side programming. This little snippet is just saying, let me know when someone clicks on the body element. When that event triggers, we want to turn the background color red. Very straightforward, no surprises. That little snippet is an example of the reactor pattern. And the reactor pattern, what it says is you have a system called a reactor, and it's responsible for listening for events and then delivering those events to the subscribe callbacks. So in our example, the reactor is our browser, and the types of events that it knows about are DOM events. Certain problems are naturally suited for the reactor pattern. So if we're talking about user input or things like keyboard events, mouse events, touch events on our tablets, it makes sense for us to register these callbacks because there's no way for us to anticipate when these events are going to happen. And it's also really nice that we have these reusable reactors, these systems that are pre-built so that every time we write something in JavaScript, we don't have to write mouse detection code, right? And the same if you're writing a game, you don't want to handle user input every time. But there are not all events have to be user-initiated or physical, right? You can define an event to be anything you want it to be. So you could say an event is when the network comes up or the network goes down, or when data is ready from a SQL query. So from the Node.js site, it says, Node.js uses event-driven, non-blocking I/O model. So we're hearing some of these terms now, but what does it mean to have non-blocking I/O? And why is that important? So I found this great photo and quote from Christian Paradis. And he says, if RAM was an F-18 Hornet with a max speed of 1,190 miles per hour, disk access is a banana slug with a top speed of 0.007 miles per hour. And I think most of us kind of know this intuitively, right? And I guess more specifically, blocking I/O is when slower devices can't get data fast enough to the CPU. And so the CPU kind of has to wait for these slower devices to have stuff to actually work on. So we know that CPUs are faster than memory, and memory is going to be faster than disk, and disk is going to be faster than network access. And the longer we have to wait, the longer we have to idle the CPU. The nice thing is our operating system works with hardware caches to kind of hide all of this from us. So in Ruby, when we say file.read, file.text, that all looks like a single operation, even though behind the scenes, the CPU isn't really doing that much work. It just kind of starts the operation, then has to wait a really long time for the disk to actually give us any data back. And the other nice thing our operating system does for us is when it notices that the CPU isn't doing anything, it can switch to other processes. So the fact that we're doing a SQL query in Rails doesn't mean that our music is going to stop playing, doesn't mean that our browser is going to stop working. So what Node means when it says that it has event-driven non-blocking I/O is that on top of the concurrency that the operating system gives us, it takes it one step further and it manages I/O at an application layer. So when you start a Node process, you're going to get a reactor, and with that reactor, you can register for when you're about to do a slow blocking I/O. And then, because registering event takes no time at all, Node can go on and do other work within its own process without switching to any of the other processes. So up until now, we've talked about evented programming in like this vague general sense. But if the operating system already handles this blocking I/O slowness for us, why do we even need to care about evented I/O for server-side programming? And the reason is even though the OSA is able to switch between processes, we're seeing a lot of waste in each of the individual Rails processes that we're starting. So inside all of our apps, I know we all do a lot of database access, file system access, which is going to touch the disk. And if we go use any external APIs, say we store something in S3, that's going to go out across the network. And even more insidiously, if we use some external program like ImageMagick, just the act of shelling out to another command and reading output from that command, that's also blocking I/O. So making this a little more concrete, if we were writing a controller action that creates a new tweet and saves it to our database, even in these 3 lines, we were seeing a lot of blocking I/O, right? So first, we create a new tweet, it's hard to say that, from the parameters. And when we go and shorten the links, we might go out to bit.ly, and that's going to be network access. When we save a tweet to our database, that's going to touch the disk. And that all happens transparently for us, which is fantastic. But from the CPU's perspective, what we're seeing is When the first request comes in, we're doing a little bit of CPU processing, waiting a really long time, and then finishing the request before we render it to our user. And that entire red space is wasted. We can't do another request during that time. So the second request has to wait until the first request fully finishes. And the way we deal with this today is to get any form of concurrency, we start up a bunch of Rails processes to handle multiple concurrent users. So if you're using Passenger with a bunch of workers or Unicorn with a bunch of workers, this is basically what you're doing, right? You're saying each of these Rails processes is going to handle one request. So we're relying on process concurrency, which works fine. The only downside is we're chewing through a bunch of memory to have all of these Rails processes going at the same time. And the worst part is for the amount of memory we're consuming, each of these processes can only handle one request at a time. If we were to write this same code with Node, it might look something like this. And the main difference is instead of having each line of code run one after the other, whenever we're about to do blocking I/O, we register a callback. So we don't actually wait for Bitly to return with our response. We just say, when you're done shortening our URL, call this callback. The same for the database callback. And if we were the CPU, what this would look like is first we would start Node, which is the top green line. And that's the reactor running. Then when the first request comes in, we do a little bit of processing. But because all we're doing is registering callbacks, that action completes almost immediately, and we're back into reactor land. Meanwhile, we've started the blocking I/O, but the reactor is able to kind of handle more incoming requests. So while the blocking I/O is happening, the reactor says, oh, I'm seeing another request. Let me start that for you. Sometime later, when the blocking I/O actually finishes, the reactor calls our callback, and we can finish the request. Same with the second request. So one thing to notice is that even though it looks like we're handling multiple requests, or we're able to handle more requests with one node process, at any given time, only one thing is running at a time. So none of these requests are actually running side by side, right? The main benefit we get is during the red sections, we're able to start new requests. So if we drew the same kind of diagram, in Node, each process is able to handle more requests. So because of that, we don't have to start as many Node processes as we would for Rails processes for the same amount of load, right? And the other thing is, if one Node process is kind of getting filled up with work, we can start another Node process, and we still get operating system process concurrency, and it can switch between different Node processes. The overall result is you need fewer processes, so there's less memory being used, so your EC2 bill costs less. One important distinction to note is the difference between latency and concurrency. So even though the Ruby version can only handle one request at a time, if you only had one request, going through either versions of that code would take the same time, right? Just because we're using evented I/O doesn't make our disk magically spin faster. So if your requests are slow to begin with, I really recommend optimizing response latency first, because that's what your users are going to notice. The Node version does handle more concurrency, but there's a trade-off for this kind of improvement. Suddenly, if we look at our application code, we're aware of blocking I/O, right? Before, we just had to say shorten links, and then the next line, I know that's done, right? Here, we're basically exposing the fact that shorten links and save are both blocking operations. And really, in our domain, we don't need to know that. A tweet shouldn't have to know that internally under the hood, we're doing blocking I/O. And being a Ruby snob, we all know the benefits of Ruby is being very easy to read and easy to kind of get the intent of the code. And with this, to kind of keep the operation of how the callbacks will be executed, you have to nest them, and you get kind of this callback spaghetti. So we saw that Node gives us better concurrency in the back end, but can we kind of get some of these same benefits with evented Ruby? And if we do it with evented Ruby, what are the trade-offs for that, right? Because maybe it also doesn't come for free. The nice thing is Ruby is capable of evented programming. I think by default, we all use it in a procedural way. But Ruby is multi-paradigm in the sense that you could use it procedurally. You could add a library in order to use it as a reactor or with reactor-aware code. Or you could even use threads and do parallel computing. And the nice thing, both a nice thing and a terrible drawback, is you can mix and match these paradigms. So within the same code base, you can have procedural code running right next to evented code. The first step for us to do evented I/O is to add a reactor. And in Ruby, a reactor is just another library, right? So the most popular library for a reactor is EventMachine. And because there's no assumption that you're going to run evented code, you have to explicitly start the reactor yourself. In Node, as soon as you type Node and then your script, you're already running in a reactor. But in Ruby, you have to say, EventMachine, run this block. This is the reactor loop that we care about. And rather than starting a reactor on your own with code, it's nice to know that a lot of the application servers we use already have a reactor built into them. So if you're using Thin, you already have EventMachine reactor running inside. And if you're using Unicorn, then Rainbows is kind of the analogous system. It has the same model, but it has an EventMachine reactor inside it. And even with Passenger, it's a bit more involved, but you can patch it to run your code within a reactor as well. So now we have a reactor, but the reactor is only half of the equation, right? We still need to have events and callbacks for those events when they happen. So this code is a small example of how you could use a reactor-aware HTTP library to fetch a web page. So this comes bundled with the EventMachine, or it's a separate gem, but it's namespaced under EventMachine. And here, I mean, if we read it, it says, create a new request object with this URL. It's a GET request. And when the request is finished, do this callback. So that's the registration phase where we're registering for that event. So inside our reactor loop, this means that even if RailsConf2012.com takes forever to load, we've registered the callback and we've stopped caring. And the reactor is free to do any other tasks that come along. But unfortunately, this has the same code smells that we were talking about earlier, right? Suddenly, when we're writing code, we're dealing with kind of manipulating the scheduling of I/O by ourselves. And I think even worse than that is this doesn't really look like Ruby, right? Syntactically, it is Ruby. It's valid Ruby. But this isn't what I would write if you told me, fetch me a web page, right? Instead, I might write something that looks like this, right? And even if you're not familiar with Faraday, this makes a lot of sense because you're saying, some library, get me a web page. That returns me the response. Behind the scenes, I don't know how this is run, but this is kind of the interface I'm giving, and it's a procedural interface. Fortunately, with a bit of extra work, Ruby lets us hide blocking I/O and its related callbacks and spaghetti inside of libraries. So Faraday is an HTTP client that lets you switch between different adapters. And by default, it uses net-HTTP, which is going to be a blocking library. But if you just add a line to configure Faraday to tell it that you are running inside a reactor, then suddenly it knows that it should register a callback, and at some later point, that callback will be called. But the nice thing is, the interface does not change. We still use Faraday the way we expect it to, but behind the scenes, it's running in this kind of evented manner. So the point is, it keeps our application code clean, and we can hide the callbacks in libraries. The way this is achieved is by using Ruby's fiber objects. And from the docs, it says, fibers are primitives for implementing cooperative concurrency in Ruby. Basically, they're a means of creating blocks that can be paused and resumed, much like threads. The main difference is that they are never preempted, and the scheduling must be done by the programmer and not the virtual machine. So if we drew out that HTTP request, it would look something like we have the reactor running. We start the request. When it's blocked on I/O, we pause the first fiber, the fiber that's running our reactor, and we, shoot, sorry, I got that backwards. So the reactor is running. When we start the request, we make a new fiber. When we're done registering our callback, we pause the request fiber and yield control back to the reactor fiber. Then in the callback, we say, oh, let's finish doing the rest of the processing we were going to do with the request. So same code smell over and over again. Now we've switched from the code doesn't look ugly anymore, but somewhere in some library, we still have to do this pausing and resuming of the fibers, right? The virtual machine will never say, this fiber is blocking the reactor, please stop and run the reactor. You have to manually say that yourself. And yes, it is introducing a bit more complexity, but it also gives us some flexibility and control over where we add this complexity. So in our tweet example, our domain model is tweets. And my main problem with that was tweets shouldn't know how you shorten links. Tweets shouldn't know how you save to a database. And with this model, we can actually hide all of that, right? A database adapter does need to know how to deal with I/O. That's within the domain of a database adapter. So I think it's reasonable to have a database adapter writer have to kind of think through the logic of scheduling the I/O, but you as the app developer should be able to use that database adapter in the way you expect it to. There is an exception to this. So even though we can hide evented I/O behind a procedural interface, sometimes the subject of what we're talking about is the event itself. So in this example, we're using blocks as a way to register for publish events in Redis. And we don't want to hide this in any way, right? Very much like how when we want to detect a mouse click, the mouse click is what we care about. So if the event is what you care about, it doesn't make sense to kind of sweep the details under the rug. So we have a reactor, and it's our app server. But for the reactor to be able to kind of switch between requests in the same process, we need our requests to be running in a fiber as well. Luckily for us, web requests are independent of one another, right? So conceptually, that makes sense that we could just wrap them all in their individual fibers. And once we achieve that, then the reactor is going to be able to switch between requests in the same process. And because Rails is rack, and rack is awesome, there's a gem called rack fiber pool that you can insert to the top of your Rails middleware stack that will basically wrap each incoming request in its own fiber. And if you're not using Rails, if you're using Sinatra or Grape or any other Ruby web framework, you can do the same thing. So you can have this same model for different web frameworks, which is very cool. So we've done some shuffling around. Things are sounding pretty good. The only infrastructure change we've made is maybe use a different app server. But you might be using one that's already Reactor aware already. The only code change we've made is we've made the requirement that every request has to be in its own fiber. And that was a one-line change, right? The rest of our code, our models, our controllers, our views, they're all still the same. And because we've done so little work, if we try to benchmark this application, you're going to notice it still sucks. It's still going to be as slow as when you started. And the reason for that is all of your code right now does not know that you're running inside a reactor, right? So like I was saying earlier, a fiber has to be manually paused and resumed. So if we're serving an incoming request, we're doing a little bit of green, then we hit an active record call. Active record doesn't know that we're in a reactor, so it's not going to give up control back to the reactor and just keep running. So we're stuck in this red. It's a blocking library. And say a second request comes in while that first request is blocked. Well, the reactor is also blocked. So there's no way for the reactor to say, started in a new fiber. So we're kind of screwed. And when that first request finally finishes, that's when that queued request can finally start. But really, this is OK. Don't freak out, because we haven't done that much work. We didn't gain any performance out of it. But hey, nothing is horribly wrong either, right? Nothing is slower by an order of magnitude. And the reason is, even though we're running in a reactor, process concurrency continues to work the same way. So maybe our reactors can only serve one request at a time, but that's what we started with. And from here, we can only improve, right? As soon as we start making our code reactor aware, that's when we start seeing some of the real benefits. So a few broad areas for starting points. We kind of touched on this when we were starting out. These are common libraries we're going to use. These are common things that are going to do blocking I/O. So from your data stores to when you do external access to APIs, or when you're shelling out to different commands. As far as your data stores go, some of the adapters you're using, it might just be a configuration change to let it know that you're running in a reactor. Otherwise, there's another gem called EM Synchrony. And this gem will have a bunch of files in it, which are basically patches to existing adapters that make them reactor aware. And on the EventMachine wiki page, they kind of have a full list of all the protocols that have either been patched or natively understand EventMachine. For HTTP, I really recommend using Faraday. I like Faraday because you can swap out different adapters. And even if the different adapters have different feature sets, Faraday kind of normalizes all of that for you so that you get the same interface. Again, I think the coolest thing about Evented Ruby is the fact we can keep the interface we want to work with and be able to gain extra concurrency. Other niceties Faraday has is it has a kind of rack style of architecture, so you can actually make middleware for handling the request before it gets sent out, and also middleware for post-processing of the request. And for system calls, EventMachine provides kind of the analogous versions of what you would expect in the kernel module. So instead of calling kernel.popen to open a process, you would call EventMachine.popen. And this is the non-blocking version. Basically, this code will run, and when the result is done, the callback will be triggered, and the result will be fed back into the reactor. And if you have a chunk of synchronous code and you can't figure out some way to make it reactor aware, or you don't want to, you can also use em.defer. And what this does is EventMachine starts by running in its own thread, not its own fiber, in its own Ruby thread. What em.defer does is it will run that chunk of code in a separate thread from the reactor thread. So now, even though your code is running at the same time as the reactor, it's not going to block your reactor. When the result of that thread finishes, again, that value is fed back into your reactor, and you can do something with that. So after we've tweaked our libraries to be reactor aware, maybe we haven't found every problem that is blocking, but we might start seeing some improvement, right? And this diagram suddenly starts looking a lot like the Node.js version of the diagram, where we have our reactor running in one fiber, and whenever there's a red section, the reactor is running rather than the red section. And because the reactor is able to dispatch new events, we're able to kind of wrap up new requests as they come in, even though we're doing blocking I/O somewhere else. If you do spend some time trying to add evented Ruby to your Rails app, you're going to get some clear benefits. For one, I think the types of changes you want to make are ones that don't touch your existing code. I'm really not advocating that you go into your controllers and start writing kind of this callback style of programming, because it's just very hard to read, and it's not worth the time. Again, it goes back to how much benefit you're going to get for the amount of work you're going to put in. The other pro, which could be a pro or a con, it's kind of lame, is that performance won't be worse, right? So we're starting with one request for a several hundred megabyte in RAM Rails process, right? Any improvement we can get is going to be something better than one request per process. You get to keep your Ruby code looking like Ruby code. It's going to be a much more readable code base while giving you more concurrency. And also, because Ruby can do evented programming and can do procedural programming, you can kind of pick and choose which scenarios make sense. So if you have a problem that you know clearly needs to be very concurrent, very near real time, that's where you stick EventMachine in. And that's where you kind of have evented programming for an evented problem. And if you find out that it's too much hassle, or it doesn't work, or it's not something you like, then maybe you can try out threads, because Ruby can also do threads. And suddenly you can experiment with JRuby and gain concurrency in a different style. You're not limited to kind of one choice. That said, because it's multi-paradigm, there are a lot of headaches involved. One of the great things about Node is it says you must use evented non-blocking I/O. And that mandate has made all of the libraries Reactor friendly. So out of the box, when you install a Node library, you know that it won't block. So you don't have to go through your code and kind of hunt for the things that are going to slow down your app. And the other big kicker, and the thing that kind of annoys me more, is the Node community is just much more active than the evented Ruby community. So if you run into a problem with evented Ruby, you might go on the mailing list. It might take longer for someone to respond. If you do some Googling, you might not find as many results. And that's tricky, especially in real life when we have to write apps. If someone says, get this working, get this to a reasonable cost, you can't just say, because I love Ruby so much, I'm going to force this way, even though there's just more work to be done than actual value. So wrapping up, evented programming is hard. It's going to be hard in any language we do it in. It doesn't matter if it's JavaScript. It doesn't matter if it's Ruby. If anything, for the Reactor pattern, JavaScript is actually a bit more natural because we're used to it from the browser. As much as we can, I think we should strive for using evented programming for evented problems. It's unfortunate that kind of the core focus of Node is this improvement in I/O concurrency. We're web developers. Why should we even care about I/O concurrency? Eventually, things will just be faster, right? But again, in real life, we do what we have to do. And before going down the evented programming route for concurrency, fix your server response latency. Even if you don't add in a reactor and wrap everything in fibers, if you just decrease your response latency, then your same app servers will be able to handle more requests because they'll finish faster, and those app servers will free up and let you do more incoming requests. And the most important thing from kind of exploring all of this was figuring out that you need to avoid evented I/O interface in your code, right? The most important thing is that your domain logic isn't polluted by kind of these I/O callbacks. The only place where I/O callbacks should exist are libraries that deal with I/O. And then those libraries should provide a procedural interface that your business logic can use without realizing what's going on under the hood. I kind of went through that a little quicker than I thought. So thanks, everyone, for listening.